Good morning. My name is John Vincent Tanglao, and I will be discussing classification of software quality metrics. Software metrics can be classified into three categories: product metrics, process metrics, and project metrics. Product metrics describe the characteristics of the product such as size, complexity, design, features, performance, and quality level, while process metrics are characteristics can be used to improve the development and maintenance activities of the software. And lastly, project metrics. These metrics describes the project characteristics and execution. Examples include the number of software developers, the pattern over the life cycle of the software, cost, schedule, and productivity. Software quality metrics are a subset of a software metrics that focus on the quality aspects of the product, process, and project. These are more closely associated with product metrics than with project metrics. Software quality metrics can be further divided into three categories: product quality metrics, in-process quality metrics, and lastly, maintenance quality metrics. In product quality metrics, these metrics include the following: mean time to failure, defect density, customer problems, and customer satisfaction. When we say mean time to failure, it is the time between failure. This metric is mostly used with safety critical systems such as the airline traffic control system, avionics, and weapons. Defect density, this measures the defects relative to the software size, expressed as lines of codes or function points, etc. It measures code quality per unit. This metric is used in many commercial software systems. Customer problems, this measures the problems that the customer encounter when using the product. It contains the customer's perspective towards the problem space of the software, which include the non-defect oriented problems together with the defect problems. And lastly, customer satisfaction. Customer satisfaction is often measured by customer survey data through the 5-point scale that we usually know, uh, which is very satisfied, satisfied, neutral, dissatisfied, and very dissatisfied. Satisfaction with the overall quality of the product and its specific dimension is usually obtained through various methods of customer survey. Based on the 5-point scale data, several methods with slight variation can be constructed and used depending on the purpose of the analysis. For example, you can classify it to percent of completely satisfied customers, percent of satisfied customers, dissatisfied customers, percent of non-satisfied customers. Next, in-process quality metric. In-process quality metric deals with the tracking of defect arrival during formal machine testing for some organization. This includes defects density during machine testing, oops, defect arrival pattern during machine testing, phase-based defect removal pattern, defect removal effectiveness. In defect density during machine testing, defect rate during formal machine testing or testing after code is integrated into the system library is correlated or connected with the defect rate in the field. Higher defect rates found during testing is an indicator that the software has experienced higher error injection during its development process, unless the higher testing defect rate is due to an extraordinary testing effort. This simple metrics of defects per clock or KLOC or function point is a good indicator of quality while the software is still being tested. It is especially useful to monitor subsequent releases of a product in the same development organization. Defect arrival pattern during machine testing is the overall defect density during testing will approve only the summary of the defect. The pattern of defect arrival gives more information about different quality levels in the field. It includes the following: the defect arrivals of or defect reported during the testing phase by time interval or let's say week, months, etc. Here, all of which will not be valid defects. The pattern of valid defects arrivals when problem determination is done on the reported problem. This is the true defect pattern. And the pattern of defect backlog over time. This metric is needed because development organization cannot investigate and fix all the reported problems immediately. This is a workload statement as well as a quality statement. If the defect backlog is large at the end of the development cycle and a lot of fixes have yet to be integrated into the system, the stability of the system, hence its quality, will be affected, which lead to retesting or regression tests is needed to ensure the targeted product quality levels are reached. Next, we have the phase-based defect removal pattern. This is an extension of the previous defect density metric during testing. In addition to testing, it tracks the defects at all phases of the development cycle, including the design reviews, code inspections, and formal verifications before testing. Because a large percentage of programming defects is related to design problems, conducting formal reviews or function verification to enhance the defect removal capability of the process at the front end reduces or error in the software. The pattern of the phase-based defect removal reflects the overall defect removal ability of the development process. With regard to the metrics for the design and coding phases, in addition to defect rates, many development organizations use metrics such as inspection coverage and inspection effort for in-process quality management. Defect removal effectiveness. This can be defined as follows. DRE or defect removal effectiveness is equal to the defect removed during a development phase over defect latent in the product times 100%. This metric can be calculated for the entire development process, for the front end before code integration and for each phase. It is called early defect removal when used for front end and phase effectiveness for specific phases. The higher the value of the metric, the more effective the development process and the fewer the defects pass to the next phase or to the field. This metric is a key concept of the defect removal model for software development. And lastly, uh, not lastly, maintenance quality metrics. Although much cannot be done to alter the quality of the product during this phase, following are the fixes that can be carried out to eliminate the defects as soon as possible with excellent fix quality for maintenance. Fix backlog and uh, management index, uh, fixed response time and fixed responsiveness, percent delinquent fixes, and fixed quality. So what is fixed backlog and backlog management index? Fixed backlog is related to the rate of defect arrivals and the rate at which fixes for reported problems become available. It is a simple count of reported problems that remain at the end of each month or each week. Using it in the format of a trend chart, this metric uh, can provide meaningful information for managing the maintenance process. Backlog Management Index or BMI is used to manage backlog of open and unresolved problems, which can be defined as BMI is equal to number of problems closed during the month over number of problems arrived during the month times 100%. If the BMI is larger than 100, it means the backlog is reduced. If the BMI is less than 100, then the backlog is increased, vice versa. Fixed response time and fixed responsiveness. The fixed response time metric is usually calculated as the mean time of all problems from open to close. Short fixed response time leads to customer satisfaction. Uh, Obviously, the important elements of fixed responsiveness are customer expectations, the agreed to fixed time, and the ability to meet one's commitment to the customers. Percent delinquent fixes is calculated as follows. Percent delinquent fixes is equal to number of fixes that exceeded the response time criteria by severity level over the number of fixes delivered in a specified time times 100%. And lastly, fixed quality. Fixed quality or the number of defect fixes is another important quality metric for the maintenance phase. A fix is defective if it did not fix the reported problem or if it fixed the original problem but injected a new defect. For mission critical software, defect, uh, defective fixes are detrimental to customer satisfaction. The metric of the percent defective fixes is the percentage of all fixes in a time interval that is defective. A defective fix can be recorded in two ways. Recorded in the month it was discovered or recorded in the month the fix was delivered. The first is the first is customer measure. The second is a process measure, which is you calculate you record it in the month where it was fixed. The difference between two dates is latent period of defective fix. Usually, the longer the latency, the more will be the customers that get affected. If the number of defects is large, then the small value of the percentage metric will show an optimistic picture. The quality goal for the maintenance process, of course, is zero defective fixes without delinquency. And that is all for classification of software quality metrics. Thank you.